Hello and welcome back. Build Stuff 2021. You are on the Saturn stage and we have just two more speakers left until we are done for this conference. Our first speaker that I would like to invite to the stage now is Rimantas Benetis. Hi, Rimantas. I hope I did that justice pronouncing your name now.
Close enough.
Thank you so much. You're very kind. Where are you joining us from today?
Yeah, so I'm joining for you from Chicago, so it's pretty early. Early there, having my coffee, ready to go.
Coffee is always good this time of the morning, or your time of the morning, I should say. And well, if you're ready to go, then I don't want to steal any more of your time. Rimantas, the stage is yours. Take it away.
Thank you a lot. Thanks a lot. Thanks a lot. So welcome, everyone. My name is Rimantas, and today I will be talking a little bit about the ML plumbing. So we will not deep dive into any ML bits, but I wanted to talk about everything that's around it. So let me give you a little bit of my background. I am working as a technology director at DevBridge, and my primary function is actually to talk to the clients and be involved in multiple projects. And in a lot of cases, we are getting the request, which is coming related with the ML part. So technically, we are not doing the ML, but everything that's around it, that's kind of our realm. So just to start off, I wanted to start kind of with a story. It's like once upon a time, we already been there, and we already kind of done that before. Sometimes the business comes up with the idea, and the ML is as it's on the trend. They come up with the idea, they start doing the POCs, they create something that's visually appealing or kind of makes sense for the business. And as soon as that's done and the business realize that it could be kind of the thing that's valid for their product, they actually come and they say like, okay, so we have the POC, that's already ready. It generates us the results. It looks valid. And they just kind of come, let's go to the production with all of this. So what does it mean? What does it mean to go to the production with the POC? So we know that from the software perspective, that it's not that easy. There are a lot of steps involved to make a product. There are a lot of steps involved to move from POC to the product. And there are some facts on the ML part that even if the POC is made, there are a lot of initiatives done. The Gartner says like at least 85%, they would not deliver. What does it mean? That means that they will stay in the POC stage. It's not going to make it to the production. It will be just a toy that was created. It will not produce any business value. And it was happening similarly with multiple technologies. Any new technology goes to POC, then everybody starts working. So how do I productionize that? That takes a lot of time. And this is what I'm going to talk today, at least the capabilities that are needed for the ML to go into the production and be fully productionized. Why should we care? So it could be a question, why should we care? We can do the POCs. We can kind of skip the production part. And I think it's important to understand that we as an engineers, we know what we're doing. We should be consulting business. We should be saying what capabilities are required. What do you need? What do you need to make it production ready? How much effort that's going to be involved? Do we want to venture into this? So instead of spending time just doing POC, rather, maybe we should be building the capabilities to go to the production. And typical kind of example, we do have the clients that approach us. They do give us some ML code and they just say, just make it into production. And what happens is it's simple. You just kind of put it in, it starts burning. You try to put the fire out and just close all of it. That's kind of a reality of it. Somebody just kind of sweeps it under the rug. So let's go and look at the landscape for the ML bit, and what's that in that plumbing, what we're looking at. So if we're looking at the landscape, all of it, ML code itself or ML models, it's really just a tiny bit of everything that should be kind of around it. There are plenty of stuff that needs to be done before you can streamline the ML. And I'm talking not just the ML that that's fixed, that the data is not changing, you can kind of put like simplified version, it could live for a long time. I'm talking more around the ML that has a large data sets coming in. Those data sets are changing in time, the values are drifting, and you need to retrain the code, you need to redeploy the code, you need to repeat that same process multiple times. And if you are looking at the landscape, it's plenty of things that has to be already there. And all of these things, if we look at each of those boxes separately, these are big things. So these are the capabilities on its own. The data collection, that's a big piece. You're not just getting like Excel files. Those are kind of ingestion pipelines. The data verification and actually correctness, the feature extraction, the training, compute resource management, the service infrastructure, this like all of these bits and pieces are really large ones. And we need to make sure we have those capabilities in one way or another. It could be at the various maturity levels, but in order to create a automated pipeline for all of it, it needs to be there in one way or another. Either you're using the tool that kind of puts multiple boxes into one, or if you're building it out yourself, that's, but still, it has to be there. So let's look a bit what's a typical machine learning workflow looks like. So the data comes in, you have to create a training set, you have to create a test set. So it's, you have to split. Also, you have to make an assumption that the data is clean, the data is correct. You pass the training set into the algorithm. That's what you're creating. That's the ML bit. You evaluate its performance. You tune the algorithm. Again, you rinse, repeat. As soon as you're happy with the model, you actually have to push it out into the production. It works in the production. It does the prediction. You have to monitor still the correctness of those prediction. And if you see there is a large enough drift, you have to go back to the data again, make that loop again. So let's look a little bit from CICD pipeline or the pipeline perspective. So this is a typical generalized pipeline for actually getting the code out. So you do the coding, you do the builds, you do the testings, you store the artifacts, and you promote those throughout the environments and doing various tests along the line. And this is just for the code. So if we're looking at the ML piece, if you're unable to do the code deploy, the normal pipeline, it will be very difficult for you to get the ML working as well. So if we're looking at the ML part, that becomes way bigger. So we have additional pieces that needs to be added to the pipeline, and that's getting the data, producing the sample set, training the model. Again, the model is being deployed as a software bit. You have to collect the data from the production, monitor performance, and rinse and repeat. So that means that if you are unable to do the normal product deployment, you should concentrate there before you actually go into the ML part. As reality is a little bit different. So if we're looking at the reality part, it would be very interesting what the data scientists are doing. So I took some statistics from Forbes, which were published by Forbes. And the interesting part that if we're looking at the data scientists, what they're doing, the majority of their time is actually cleaning and organizing the data and collecting the data sets. So it's the huge amount of effort is actually going not into the ML bit, but actually just getting the data and trying to clean it up. The whole kind of algorithms and everything is just like 4% in all of the work that they're doing. And if we're going back a bit into the whole landscape piece, we can see that, okay, so ML code, it's like 4%, and then everything else is spent into the other places at the data collection, data verification, like feature extraction bits. And this is the reality. This is what we're seeing with our clients. The data is very difficult to come by. The data that's available is either dirty and it is just not usable until the data scientists kind of get to it. And the interesting part that the data scientists itself, where they kind of, what do they like or not, it's like what they do, what's least their kind of option would be. It's exactly what they're doing most. So technically, the cleaning and collecting the data sets is the ones that they don't do. They want to get actually to the algorithms. So what I wanted to go through now is talk a bit about the things that are important and that you should be considering if you're building a product, that you should be considering and have like a plan or strategy to have in your product to build it out and to use it in order to productionize those ML bits and in order to have a clear pipeline, a clear way to deploy it, and clear way to monitor so it's useful and actually brings the value. So let's look at the big pieces that are important, and then we can kind of deep dive into each of them and see what's there, what capabilities should be built there, and what's important. So first thing is the data abundance. The data abundance, that means it should be easy to get the data. It should be easy to get the data for data scientists. It should be easy to find it. As we watched previously, the most of the time is actually spent into sourcing and cleansing the data. So in an organization or product, you have to have a place, a way to actually access the data and get proper outputs out from there. The other bit, I already talked a bit, this is the data correctness. And the data correctness is often overlooked. The data is dumped into the data warehouse, the data lakes, as it is. Nobody looks at the correctness of the data. And as soon as the data scientist actually starts working on those, they realize that either the structure is not right, it could be that the data is biased, there is not enough samples, the samples do not kind of match together, and it kind of pulls into those cleansing things, analytics things, kind of to get those in place. And the other interesting part is that even if they cleanse it into their kind of local space. And that means that all of the transformations or cleansing tasks that they've done, it actually never makes it back into the source. So I think this is the important piece. The data flexibility, and that means that as time goes, the data changes, the data structure changes, the data bias changes. So the whole infrastructure of ingesting data, storing data, or how you manage data, it has to account for the data flexibility. You will be getting more sources for your products. You will be getting more data. The data will be changing. The attributes will be appearing. Some of them will be disappearing, maybe changing their shape. All of the storage, ingestion pipelines, they have to account that data flexibility. If you build out it rigidly, it will be a lot of problems actually to maintain it later on and have a healthy ML pipelines or the plumbing. The other part is also a very important but oftenly overlooked bit is the model validity in time. That means even if you build out a model and it works today, that does not mean that it's still producing correct results tomorrow. What do I mean by that? Sometimes the models are pretty rigid. So they stay as it is, but in a lot of cases, the data changes, the data bias changes, and your model will perform worse and worse in time. And if you have no means of monitoring that, your performance of the model, you will not detect it. And soon it will be performing worse and worse, and it will bring no value. It can actually bring you even worse things because the people will stop trusting that, and it will be gone. And that's the fifth time. The fifth item is the trust of the people, or actually the users that they're using. We've seen some of the products where the ML is being used, but people are not trusting the results. It's not implicit, and it's just useless. It takes a lot of effort, a lot of resources to get it into production, but then it just is a hint or something that's not working or not being used at all. So let's kind of deep dive a little bit into each of those items and see what could be done and what are typical problems. So the data abundance, I already said, it should be easy to get to the data. It should be easy to pull the data out so it can be consumed for the ML models. There are some issues with the data abundance, which we are seeing, and the important is how do you expose the data. So what we're seeing in a market is that a lot of companies has a lot of data, but all of that data is stored in silos. So each department might have a bit of information, and that information is in that department only. And ML kind of shines if you are able to kind of connect the dots. You can actually get the access to all of those silos and use that for your insights. So one of the things is, which is important in a company, is actually to break down those silos, to open up the capabilities, to open up the data for data scientists to grab and to use. And this is a very important bit because it boils down that you have to have a single source of truth. And that is maybe easier said than actually done, because all of the departments sometimes run in their kind of isolated way. They have their way of defining the data. They have their way of storing the data. They have the different shapes of the same data, and that becomes a big problem on its own. So, so first step to actually to go and open up those data sets is actually to break down the data silos. You have to make sure that the departments are talking. You have to make sure that the data actually makes to one place, and there is a single source of truth for data scientists to pick it up. The interesting part is that the data sometimes comes from single source and it breaks down into different departments, and the cleansing that's done is different. So putting the data into one place actually allows you to simplify the data cleansing part. And if the data scientists from one department already done that, they can do that on the single data source of truth, and it automatically gets better, not just for the data science, it gets kind of corrected for use in the product itself. So you are getting kind of some value from there as well. And the third item is it allows to see the big picture. So if you can concentrate, if you're building the product that's using multiple data from multiple departments, it's obvious that if you have only one silo, you will not be seeing a big picture, so you will be getting some skewed results. So this is also important. If you break down the silos, if you move them to single source, you can actually start seeing the big picture. You can cleanse them up and have a nice, clear picture on the data that the organization owns. The next item is the data correctness bit. The data correctness, it's important because sometimes you might have the data, and the data, you can access the data, maybe you have it, but the data correctness is important to build the proper models. You might be missing some of the values. That's easy maybe to detect, but there is in some cases that the data is skewed. And if you are building a models from the data, and it has some dirty data, that is, it's not like all of the points that are bad, but there are some dirty items in place, it will skew your model. So let's go through some samples and see. So for example, we have an ideal model with the clean data. We can see it should be just like 45% slope. And we can do the predictions correctly. So what happens if we have all of the data that's incorrect? We might get a totally inverted graph, and our predictions would be way off. So for these kinds of errors, it's pretty easy to detect because you will be so off that you will immediately kind of dig down and see where the problem is. But if you have those items mixed together, so you have the good data and the bad data together, that becomes way more complex. And the biggest problem is that it's very difficult to debug these kinds of items. There is no easy way to tell that it's mixed up. You are getting maybe correct trends, but you are not getting a good model. So it's very important to keep the data correctness, and you have to go into the source. The other part is also that it could be that you have a clean data, but it does not represent all of your data set. So if looking at the clean data, I've removed the points, some of the points, and it's a subset, and you can also see that your predictions will be off. So it's very important not just to have the good data, but also have a healthy data set. So this is what's going from the data correctness point. And it has to be sorted out at the source level, not after, because that data will follow you throughout all of the products and all of the life cycle. So to sum up, it's you can clearly see that you can get a very different results if you mix up or have like biased data sets. So it's important to go to the sources and make sure that the data that's entering there is correct. So you don't have to debug them back from the ML model. It becomes, I would probably say it's like a unit testing from integration test, building the ML. So it costs a lot because you have to build out the ML. It goes through all of the cycles, you use up resources, and then you find that something is off, and then you have to backtrack to the data source. So you have to have a capability of getting that correct data into your data sources. The other bit that I talked about is the data flexibility bit, and this is pretty clear because the data flexibility, you have to know that it's going to change in time. There is no way the data is going to be same throughout the time. Unless your product is really, really living a short time. So it will change. You will get more data, as I said, you will get more data sources, and it should be easy to change, to ingest that data and to apply that data. So let's look at typical things that we're seeing for the clients. So the typical bit is you get a piece of data. It could be SFTP, files, buckets, whatever. The ETL processes that bit and actually pulls the whole stuff into database. And then the database is used as a source to pull that information. The interesting part that this is a very simple stuff, and as soon as you get more products, you get a lot of these things. And you get multiple SFTPs, multiple incoming files, we get kind of multiple database. Then at some point, the company decides to actually pull the data and try to aggregate into some data warehouse. So there is another ETL work that's pulling the data. And it's not just that. Then as soon as the data makes it somewhere, it kind of, the big data version just kind of pulls kind of more on it. So it pulls the data from maybe multiple data sources, multiple data warehouse, puts in the data lake. The other sources are connected to the data lake, and that is becoming a mess. If you see that if I change something on some of the structures, so we can even expand it even more, we get some applications built out on top of it. We built out some ML sandbox replications. And the problem with this approach is that if there is a change in one of the databases, the initial ones, it has to propagate through all of it. That means all of the ETL bits needs to be changed, the data lake structures, and it becomes a big burden for the product. And from experiences I've seen that it's just drops. Somebody just tries to search or build out another pipeline that sits on those databases or another replica of the database, and it becomes very rigid. So to add additional bits into those databases or data stores, it's very difficult. It's tedious tasks. Nobody wants to take them on. That means you are missing out on the ML bit, getting that data, building some models and firing. Another bit, as I already said, with the correctness part is cleansing the data. So to cleanse the data in this kind of structure, it becomes also very complicated. If we're looking at the ML sandbox bit, so data scientists would be typically working in that sandbox bit, and they will cleanse the data in that sandbox. As soon as the sources changes, they will not be able to apply that retrospectively. So I think it is important to have a flexible kind of ingestion bits that are not coupled together, but rather either going through event streams or some simplified structures that you can always expand, you can always get additional data models. And the data should be possible to branch out for experimentation, to branch out for specific analytics, because you might need only a subset of data, and it could be multiple departments doing those bits. So it should be possible for them to quickly get the data up, kind of replay the model, build out the model, and use it kind of independently, and always have a connection with the ingestion bit, and always move the cleansing bits as well as close to the source as possible. This will allow the system to grow, to get more data, get more modeling in place, and easier kind of management of the data. The next thing is the modal validity in time. So even if you have the correct data sources, even if you have correct data, it's not necessarily going to be always like this. So it is very important when you build out the model, you need to have infrastructure that is able to monitor the performance and actually give you some hints that hint either the model rebuild or you need to sample more data. So without this, if you push the ML models into the production, you will never know how they're performing. So you need to evaluate the performance before it goes out, and you need to have some thresholding and monitoring in place that will allow you to figure out if the model is still behaving as it was behaving before, or do we need to go back and retrain the model with new data and redeploy it. And it needs to be understood. It's not, there is no tool that you can buy and that will show you. It needs to be built into the product. So there are various ways to capture the performance. So it could be that it needs the input from the user. Was the recommendation correct or not? Or it should be kind of looking at some behaviors. So it's not that simple task. It's a design problem. It needs to be coded, it needs to be deployed, and it needs to be working as expected. So this is also a very important bit and oftenly overlooked. So the people build out the model, they have some code snippet, they push it into production, but the product itself does not support any way of monitoring was the prediction correct or not. There is no way kind of to understand what's going on in the production. And then oftenly overlooked bit, because this is not a technical bit, but this is more about the human factor, about the trust. And I've seen the products where the ML is kind of working, but the people are not using it. And there are reasons for this. So even if the product provides some prediction on the ML modeling, and we can understand from the engineering point of view that it is rather good prediction that was fired, the users would actually copy paste the values into the Excel, try to do their own calculations. They don't believe that the value is correct. So I think it's important to understand and build into the product that those predictions are not intuitive. There needs to be either explanation or there needs to be some thought from, it could be from UX, UI way to explain for the people that what they're seeing or what's being predicted, that's correct. It's not kind of, or even provide some certainty, because most models do not provide like 100% accuracy. So there needs to be some work involved, and it needs to be addressed in some way or another. The other bit that's not that simple is reproduction and diagnosing the issues, because the model uses a lot of data, it's being changed, and if you hit the edge cases, it's not that easy to debug. And as soon as that hits the production, as soon as the people actually see it, it could be a sample of this one. So it could be anything, it's the same stuff, but it could be meaning from the prediction perspective. As soon as they see that it's a snowplow as a prediction, they will start distrusting the product. And as they start distrusting, it's going to be very difficult to build the trust again. They'll see it as a kind of additional bit in your product that brings no value, that they have to verify anyway, and that's not going to work. That means a lot of effort will be wasted if the people don't trust it. So there are some of the ways to mitigate it. So it's possible to do the shadow mode. So to run the product as it is, but also collect the data in parallel and compare the prediction and actually maybe manual things. That kind of will build up the trust. And as that builds up the trust, actually on the engineering side, actually we can use the canary releases to roll out those bits into a subset of people that maybe understands how that prediction works. There may be SMEs, or maybe they are early adopters. And as soon as they build up the trust, the engineering builds up the trust, the pipeline builds up the trust, and if it could be rolled out in full scale. So it's a very important bit that's usually overlooked, and it has to be kind of addressed. So just to sum up all of the things that I talked about, the ML bit on its own, it does not solve the problem. That is, there are more bits to it. So all of the plumbing capability has to be there. And just to repeat all of the things that I already talked, the companies or product companies have to invest in the data acquisition bit. So they have to make sure that the data that they're acquiring is correct, that the data that's coming in is able to flex, and it's available for data scientists to attack. There is a necessity to do the model monitoring. So whatever you create now, it's changing over the time. You need to have the capabilities to monitor the model. You need to have the capability to capture the data that's going through the product, to be able to build out new data sets and train your model on those new data sets. And also, it's always necessary to educate the users. So whatever you're building, however your product prediction works, the important part is it's rarely 100% accuracy. So users needs to be educated, because sometimes we get a requirement from clients that they want to do something, but actually the prediction for their use cases has to be accurate. It has to be 100%, and it's not the case. So it's also very important to educate the user what ML actually solves and how it helps you. And that's with that, I would like to conclude, and we can probably go to the question and answers.
Hi, thank you for that. That was an awful lot of information. It's I've been involved in the other side of an ML pipeline. I've consumed models that data scientists have built for me, but I've never seen this side before. It was extremely interesting to go through. Looking at the chat, we don't have any questions at the moment, but one of the questions that I wanted to ask, we have to do all of these steps to make sure that the data is suitable for the needs to be able to use it to train our models. Is this something that is non-trivial to automate, or is this a serious engineering job in order to ensure that the data is good?
Yeah, so this is multiple stage bits, right? It contains of multiple bits, and when we looked at the landscape, it kind of shows different boxes. So properly splitting those out, those are engineering bits. So, but the problem that capability needs to be in there. The company has to have those capabilities. They have to have that engineering bit in place. And as engineers, we need to educate the business that even if you have the ML bit that's roughly working, to make it into production, it's a lot of other stuff is involved. So I think this is kind of our responsibility for the business.
Yeah, I seem to remember that the validation of the models that we got out, that was a huge part before we could actually go to production, to make sure that our customers could trust the predictions that we were giving them based on the models that we were building, and could trust the advice that we were giving them based on that.
Yeah, and I think another bit that's important is actually sometimes you need to change the product to be able to collect that feedback. There is no easy way, like, was the prediction right for you? It has to be either a button or something like this is not relevant. So it also adds additional bits that you have to think of.
Yeah, and I seem to recall the way that we validated ours in the beginning is we got a team of 100 experts, and we gave the results of our models to these experts, and we said, would you agree with this? And we went through a lot of iterations with this to make sure that the advice we were giving was actually something that matched the reality of the world.
Yeah, and I think the also important is that if you want to keep the cycle rolling, so it's not like one-off bit, you have to build this, automate this process. That is, the process that you've done has to be automated in some way.
Yeah. Okay, I can see one comment that we have in the chat from John Paul saying, thank you. And I can totally go with that one as well. Thank you for the talk. We have a QA Zoom room where people can come and ask you questions in person if they are a little bit shy to put it into the public chat. Are you able to join that for a few minutes after we finished?
Yeah, I think, yeah, I have to figure out where they have the link, but Yeah,
we
I
can get that
join in
organized
a few
for you.
minutes.
That's fine. Thank
Yeah.
you. Thank you so much. And well, we're a couple of minutes early, but well, enjoy the extra 5 minutes to grab a drink. And we will see you back in about 25 minutes from now, I believe, at 1/4 past the hour for our last talk of the conference. I see you then. Bye-bye.
Okay, bye there.